1. This application shows how one widget can update another widget. 2. We have to change the value in the progress bars. In the Kivy file, each progress bar has to be given a unique ID, which will be updated by this function in the Python root class. Here the function newWeights is called by the slider in the Kivy file. 3. For the app class, we give the title we want in the window. The default is the class name. 4. In the Kivy file, two dynamic classes are defined. They are myLabel and myProgressBar. The common properties are defined here, such as position and size. It is better only to change here, rather than in all instances. 5. The box layout will be vertical. Here the box layout is cleared. The rest of the Kivy files defines the 6 elements in the application, the 4 progress bars, T-label, and slider. 6. The first 2 progress bars are shown here. Note, each has a label describing them. The 2 progress bars have IDs of W0 and W1. 7. The last 2 progress bars have IDs of W2 and W3. 8. Next, the T label is shown. The parameter T varies from 0 to 1 and indicates position on the Bezier curve. The position T equals 0 refers to the origin and T equals 1 refers to the destination. A label, like any widget, has its own canvas instructions. Thus we add the background color before any other graphic instructions are called. That is the reason we chose canvas.before rather than canvas. For the text, the format is used to print a floating point number with only 3 decimal places. 9. The slider is responsible for calling the newWeights function inside the root class. Also, _value is called whenever the slider value changes. It is possible to have _property for different properties. These will be called by Kivy whenever the property changes. Later, we will see how to define our own properties. 10. This is a demo of the application as T changes from 0 to 1. At T equals 0, the Bezier curve is at point P1. Then, at a T of 0.33, the curve is near P2. At T equals 0.67, the curve is near P3. Finally, at T equals 1, we will be at our final point, P4. If we have more control points, the actions will happen faster. For 5 control points, at T equals 0.2, the curve will be near point P2. 11. You can find additional information including the source code at pythonmobile.blogspot.com.